Hello everyone, my name is Brooke Orsello. I live in UK. I'm an electrical and electronics engineer. Today I will be discussing on digital signal, analog signal, and sampling. So this lecture is as an introduction for digital signal processing. What is signal? Then signal is any physical quantity that transfer or transport information from one place to another. What is analog signal? What's analog signal? Analog signal is a continuous signal that varies over time and can take on an infinite number of values within a given range, while a discrete signal is a digital signal that has a finite set of distinct values at a specific point in time. Analog signals are used to represent continuously varying physical quantities, such as a sound wave or voltage, while discrete signals are used to represent digital data such as a binary code. So let's show you some figures that illustrate a continuous analog signal. This analog signal is a sinusoidal wave that's a function of time. X of t is the signal, and it has an infinite value within a given range of time. So what is the issue with that? What's the main problem in regards to uh, digital signal processing? Analog signals cannot be read, stored, processed, displayed, and transmitted digitally. The reason is that any section of analog signal is made up of an infinite number of values, and digital devices have limited resources. Think about it. You have an infinite values of x of t or signal x of t, but you have a limited resource of hardware that processes a digital signal. You see, it's impossible to process, to store, and to display an infinite value within given limited resources. You need an infinite amount of memory processors in order to process or store and display those infinite analog signals or infinite data. So we need some kinds of operation in order to transform or change analog signals into discrete signals or digital signals so that can be processed, stored, and displayed by your digital signal processing system. So therefore, an operation to make analog signals accessible digitally is needed. This operation is called sampling. Sampling measures the amplitude of a signal at a regular time interval. So the time interval between two successive samples is called sample interval or sample period, TS. Units that's measured in unit seconds. Sampling results in a signal that has a discretized time axis, and thus the signal is called a discrete time signal or generally a discrete signal. If you take a look on this analog signal, you have an infinite values of x of t. So let's see how we can sample this. We can transform this analog signal into its discrete representation. Here we take n samples in every time interval ts or at every time interval ts. As can be seen on the figure, we take the first sample at n equals to 0 and the first period, and after the same interval of time ts, we take another sample, part of the analog signal in ts after 1 ts. So by doing that, we can take a lot of samples from the analog signals and represent them in their sampled form or in their discrete form. So what is n? N is a parameter. It's a parameter that's called sample number. Ts is also another parameter that should be taken care of when we design our digital system processor or digital system digital signal processing device. So that Ts is sample period. So within a regular interval of Ts, we take n samples of the analog signal and represent it into its discrete form or digital signal form. So as a summary, during sampling time, time is expressed in terms of nts. Before, as you have seen on the figure, the signal x of t was a function of time. It was a function of time. But now its discrete form or discrete representation is in it's a function of nts. No more t. It's the time will be represented or expressed in terms of nts, and the resulting signal in the form of will be in the form of x of nts. So the discrete signal is a function of not t but nts. So a discrete signal therefore has a finite number of measurements taken every ts seconds, but ts should be selected in such a way that its amplitude should be still continuous between its maximum and minimum values. Let's take a look from the previous picture. If you give a look on this figure, the amplitude is still continuous. It has a discrete value. It has a finite amount of value within a range of time, but it's still continuous, and we need that. So whenever we select t or sampling period, we have to take into consideration so that ts should be selected in such a way that its amplitude should be still continuous between its minimum and maximum values. So thank you for watching, guys. In the next lecture, I will be discussing on some specific or special discrete signals uh, like unit sample sequence, unit step sequence, and also I will show you some examples that highlights these points that we already have discussed. So I will give you some examples, and I will discuss I will do some further discussion on unit sample sequence and unit step sequence. So if you find this lecture is helping, please subscribe and